Guru Brahma, Guru Vishnu, Guru Devo Maheshwaraha, Guru Sakshat Parabrahmam, Tasmai Sri Guruve Namaha. God, our Creator, has stored within our minds and personalities great potential strength and ability. Prayer helps us tap and develop these powers, said by Dr. APJ Abdul Kalam. A very good morning, one and all. I welcome you all the 5-day faculty development program in additive manufacturing. In that way, today we are going to travel fourth day as a first session. Today we have with us a very knowledgeable, experienced, and motivated speaker. I like to introduce with you. His horns in physics and MBA. Worked as a group of first few employees in HCL and grew to be the general manager in charge of CAD business in HCL. Started Adroitec with a group of friends, and today Adroitec is a team of 300 professionals working in emerging the technologies like IIoT, robotics and automation, 3D printing and adaptive CAD. Hold few patent in the use of 3D printing for biomedical applications. Recently appointed as the currently representative on the ISO International Committee to define standards for 3D printing, and also as the head of one of the two committees of BIS for creating standards for smart manufacturing for Indian industry. Hope you find it sufficient. He is none other than Mr. Saroop Chand, founder and director, Adroitec Group, Noida. I welcome you, sir, for today's session.
Thank you. So I hope you can see my screen and I hope you can also hear me. Is it okay?
Yes, sir.
Okay. Okay, I think I welcome you all on the fourth day of the session being done related to faculty development program organized by NIET, and I understand the faculty from different colleges as well as within NIET is attending this session. I do not know how many of you are attending it, but
sir, there are 200 plus participants attending this event, sir.
Very good. So I welcome you all, and today I'm going to walk you through the 3D printing technology, how and why it is emerging, and what are the different applications which it is being used. Coming from the industry, it only helps me in bringing the use case studies extensively in the area of metal, plastic, as well as other material like clay and ceramic, and which is what I'm going to touch upon. So if you look at it, Adroitec as a group started working about 30 years back, but in the 3D printing area, we started working only about 5 years back. It is a disruptive technology which helps in accelerating the manufacturing, mainly because the...
Excuse me, sir. Sorry for the disturbance, sir.
Yes.
Sir, PPT yet not shown. Your screen is visible, but PPT has been minimized, I think.
Not really. Can you see it now?
Sir, it's not visible right now, sir.
I have not minimized it.
Your window is visible, sir, but your PPT is not visible. Sir, double click on the shared one.
The folder 3D printing is here. This folder.
Is it now visible?
Yes, sir. Yes, sir. It is visible.
Okay. So we are talking of 3D printing. So I'll run it in the same mode rather than full screen so that it
Okay, sir. No
helps.
issue, sir.
So we are talking of 3D printing. It is a area of one of the emerging technologies which has started happening. It helps in accelerating the manufacturing, prototype development, and able to address applications which could not be done till now. So it's an extension of what we used to do, and it facilitates that process in terms of speed, in terms of material, in terms of flexibility. That's why it has now been adopted almost in all areas of engineering, consumer products, as well as some of the fancy products which I will share with you. It is a toolless technology. So that today's agenda, we will keep it as very two slides of Adroitec, the 3D print benefits and why this technology has emerged, the technology by itself, use cases, and the different materials. Just to give you a little background of Adroitec, Adroitec has been in the emerging technologies, and it is enabling customers to be able to reap the benefit of the new technologies and be able to take a quantum jump in terms of growth. So we are today a team of about 300 people. We are 30-year-old company, and we work from about 9 offices in the country, apart from 2 offices in Germany and US. Our areas of focus have been in robotic and smart manufacturing. So close to about 100 plus people work in the robotic and smart manufacturing, where we work with companies like Ford, Daimler, which is Benz, and company like GM for Opel, and some of the aerospace companies like Bell Helicopter, Hardcore, in terms of Space Application Center, India, all of them we work. Then we also have a full team which addresses the IIoT. In terms of hardware, we work with different PLC manufacturers as well as the gateway manufacturers, and then work on softwares for ensuring that the protocols are robust and are secure. Here we have even developed an IIoT server, so you can work on any of the web server like Amazon web server or Microsoft server or any of them. In addition to that, we can also provide a server by which the user can keep the data local, at the same time can also keep it global. We have been working in the 3D printing space because many of the institutes we observed find it very expensive to hire the space on the AWS or any of the web servers. And that's why we created a facility by which the institute can create a server of their own, which can work as a global server and then can share the data so that the students can do the projects in this area. And we also developed 4 kits in IIoT for doing the process plant, for doing the digital manufacturing, for doing the quality monitoring, and also a general kit so that the student can be given the experience in all these areas. In 3D printing, which is what we are going to discuss at length, we do work with different type of printers and different type of material and for different applications. Our core is the CAD knowledge, and since we have the basic CAD knowledge, we are able to utilize the 3D printing in multiple areas. And you would see why CAD knowledge become very relevant in 3D printing. Gone are the, I would not say gone are the days, but typically we used to do the manufacturing using either an injection molding or the CNC programming. For small batch assignment, both these methods were very, very expensive. Why? Because in injection molding, we had to make a tool and die. and had to have a minimum order quantity. And if it was a CNC machining, then it used to take us a lot of time in writing the program and then testing them out, and also have the correct tool library before the manufacturing could be done. Now, these are very good for very large production quantity, but they are very uh, inefficient when it comes to small batch production, which may be 100, 200, 500 pieces, or could be not possible because the process is so traditional that in many cases it was not even possible to manufacture or attempt the lightweighting of the parts. So we will discuss how 3D printing is able to facilitate lightweighting, integration of part, in addition to taking over the role of the existing processes for small batch production. The existing system also involved high capital cost for developing the die and mold, and practically I do not think you would have seen a factory which is less than 5,000 square feet where even a workshop is doing the manufacturing. Today in my office, I have about 1,000 square feet of area allocated only for this 3D printing, and in 1,000 square feet we are able to do production worth about 5 crores every year. The lead time to develop the die and mold, setup time for part changeover. So practically you had the minimum order quantity, trials and corrective action were required. Maintenance of die for the life cycle of the product was another big challenge, and they had to be stored. Looking at the current need, the need is changing. The need is becoming more personalized. So there is a new word which has come in, mass personalized customization. So it's mass customization. Now the two words are opposite, but they are true that you need to address 100, 150, 500, 1,000 people, and the needs of the other group of 1,000 people is very different. And therefore you need to continuously do personalization, which means you need to modify your shop floor to be able to manufacture and deliver reliable product in a flexible and a targeted system. Second thing is that because of this, the product life cycle is reduced. What used to be in the good old days, and in when one used to work with people like Ambassador Car, Hindustan Motor, it used to be 5 year, minor changes in the model used to be made. Today, a company like Maruti launches about 7 different models, and in each of the model, there are at least 100 to 150 engineering changes after the product has been delivered. The third critical aspect is that the products are becoming smart. And when we say smart, they involve electronic, they involve software, they involve the mechanical and everything else. So with the smart product, you need to do the testing has to be done along with people who are specialized in different domain, and yet they are putting the product together, which means my cycle time, which is 5 products or 7 products to be launched, has to be completed in collaboration with multiple streams of people, and these streams of people may or may not be sitting at the same place, but they may be sitting at different locations, and the product may be getting serviced or delivered in a different country. So all of it poses a big challenge in terms of supply chain, in terms of quick speed, and in terms of training the people in repair of the machines or the equipment at different locations. So we have to reduce the whole time of prototyping, testing, physical working, and then be able to launch. And that is called the Industry 4.0. So from the handmade and time intensive system, which is what started the manufacturing, and the Ford introduced the mass customization, mass delivery with the same product being manufactured, no variation. And it is a very famous statement from Ford himself saying that you can buy any color in my car range as long as it's black. Now that's what Ford did, which reduced the cost, and also improved the productivity. But it was one standard product coming out. Came the computer-aided design and just-in-time machine production, which helped in reducing cost and ensuring little more flexibility. But today with the smart products, it is changing to the smart manufacturing, the flexible manufacturing, which is leading to 3D transformation. All of it is being facilitated by tools like artificial intelligence, industrial Internet of Things, which can give us the data related to the performance of the product from very, very far off places. And thereby we can build in reliability more and more in our products. At the same time, with so much of data coming in from so many vehicles or from consumer product or from machines, you need to store, analyze, and then be able to make sense to be able to facilitate decision making. On the shop floor, to make it a flexible manufacturing, we had no other choice but to introduce robotic and as a component of the flexible manufacturing system and then be able to take it forward. The fifth key technology is the 3D printing, because with this you could print tools, jigs, fixtures quickly. You could make the prototype, you could make a small batch production, and you could also produce the spare part for the maintenance of the equipment which has been supplied. It facilitates rapid innovation, and many of us are working in colleges where there are a lot of incubation centers which have come in. Now, I do remember that I have seen products from the students coming out and participating in various competition with the wires hanging, with no casing, or with the casing which has been provided by sheet metal bending or by wood cutting and things like that. That neither was sustainable nor was robust. As a result, students used to carry. Hello. अभी बाद में बात करूँगा. The students used to carry the product for display, and on the they were on the tenter hook, whether it would work or some of the wires would get pulled out, or would the mechanical system be able to sustain. With the help of 3D printing, you are able to ensure that your product is in a deliverable form, almost like an industry, and with very little time and with complications and innovation in design, which could be introduced in a very flexible manner. Shorter time to market. So there was a company which was making a mixie, and from a startup company, and he had built up some smartness in that mixie, and he wanted to launch with one model of the mixie. He came across and when he went to the die maker, the total estimate for about 11 dies was coming out to be about 60 lakh, and the time was about 4 to 5 months time. No one will give a weightage to a guy who is just a startup, because he has no relationship, he has no vendor management, he has to do everything himself. He came to us. We said, why launch one? You would have very little credibility with one set of models. Why not launch 5 different sets of models? He said, sir, one itself is so expensive. How can I do 5? So I said, don't worry. Let's try to do it through 3D printing. The total cost of making 5 different sets of model was close to about 15 lakh, and the time was about 1 month. In 1 month, he had 5 different sets of models available, which he could display in the exhibition and could launch his product with high credibility. With that, he could also get the feedback as to which are the models which he should market and which are the models he should drop or make modifications in. The entrepreneur does not have to hold the inventory either for long-term maintenance or because of the minimum order quantity which is required. This is typical for a special purpose machinery manufacturer. In a special purpose machinery manufacturer, he or she has to make a machine which is unique to meet the specific need, which means he has to keep the parts. And if he has to keep the parts for both lifetime maintenance as well as for today, no one will supply one piece. So he has to order at least about 15, 20, 30 pieces, which means he doesn't need them. And his next design get hampered because he has the inventory and he does not have that flexibility. At the same time, there is a more efficient supply chain which get built in because you can actually transfer the data in a digital form and can get it manufactured from the local manufacturer at that location. All of it is adding to the high capital efficiency as well as adding to the higher efficiency of go-to-market place. So in brief, it leads to reduced manufacturing time, no tooling, no minimum order quantity, trial of alternative to get most economic and efficient system, customized products which are lightweighting, integration of many parts, because now we don't have the problem of a tool or a die hitting and then compressing the liquid, and if there is any undercut or overcuts, you get stuck. But in 3D printing, since it's printing it layer by layer and we are not taking out anything, therefore you can create very, very complex geometry as a single piece. You can even provide hinges as a component, and by providing the hinges, you are able to integrate multiple parts. In fact, complex geometry is a big advantage in the 3D printing world. Let's look at the trends. If we look at the trends, it's being used by the motor vehicle companies, it's being used for aerospace, for industrial business machines, for consumer products, and I just attended and gave a lecture in the medical forum. It's now being used practically in the whole stream, whether it's neurosurgery or it is dental or it is planning the surgery of heart, almost everywhere in the field of medical, apart from the standard things like audiology or aligners or prostheses, which in any case are being made using the 3D printing nowadays, because human being is individual. There is no mass in shape or geometry or the person, and therefore in medical it has been adopted almost in every area. Academic institutions are adopting it because it's giving employment and it's adding the skill value to the student with which he can seek better employment than what he was doing before. Everyone knows CNC programming, everyone knows CAD. So if they know that, how do you distinguish yourself until unless you work on any of the emerging technologies, you are not in a position to get the job. Architects have started using it. Government and defense have started using extensively. Gold, the jewelers are the biggest users. Even in India, more than 200 jewelers are now using the 3D printing for the casting of the gold, and that's why they are today able to ensure the hallmark jewelry. Without that, it was not possible, because with taka or with the copper joint, you cannot achieve the hallmark. It's being used for different applications. So typically all of us know the fit and assembly or the presentation model. But now it's being used for patterns, for prototype tooling, for patterns for metal casting, which is sand mold casting. It's being used for tooling of components. It's being used directly as functional parts and the visual aid. You can see on the right side different examples of 3D printing, from a soft mold to a complex mold where the cooling channels are curved rather than straight line. Previously, all channels used to be straight line because the only process which was available was drilling, but no longer. And therefore, with the 3D printing, you are able to take the cooling channel very close to the part. And when you take it very close to the part in a direct, it gives a higher efficiency in terms of cooling, and at the same time does not leave does not make uneven cooling, which used to lead to a distortion in the shape of the parts. Across the world, it's been adopted extensively. Even in Asia Pacific, if you see, it is same as North America. Unfortunately, India has been slightly slow in adoption, and we have less than 0.5% of the global market. But I think it's very soon catching up. China has adopted close to about 10%, and even in Asia, it is close to 3.2%, which means globally, India is only at about 0.5%, which is very, very low. And I think this program will help you in taking a decision for your college, how you can adapt it. And NIET, at least I know, I started talking to them about 2 years back, and today they have systems which are resin systems, which are clay systems, which are plastic systems, which are carbon composite systems. And I think they have taken that initiative of ensuring that the students are able to work on different materials, and most of them are open source material. Brief of how it is being used in different industries. It's being used in military and defense. So practically all drone manufacturers are today using the 3D printed parts because they are lightweight, they can be in small quantity, and they could be modified very quickly to be able to give the shape to the drone. It's being used for exoskeleton, for transferring the weight from the back to the foot, and it's also being used for many other areas in defense, for equipment manufacturing, equipment testing, because you can work with even material like titanium on this. We are working on a project which is working on cryogenic system, and also a project where we are developing a silicone mixed clay by which you are able to take the temperature very, very high, and which could be used on the top of the missile as a part of the work. It's being used in aerospace for making whole lot of jigs and fixtures. So a customer like Space Application Center is today using 3D printed all jigs and fixtures. The parts are not tested for flying in the air. It would take its own time, but are they capable of flying in the air? They are very much capable of flying in the air, but the process of testing and evaluation is a 3 to 5 years time. But at the end of 3 to 5 years, there will be plenty of usage of 3D printing in the aerospace industry. In mobility, things like fluid and air duct, impellers, snap fit devices, panels, housing, grills, or even tools like jigs and fixtures, ergonomic tools, shadow boxes are all being done using the 3D printing. You can do thermoforming, you can do metal casting, you can do pattern with the sand for the sand mold casting, which is one of the very common way of creating the parts either in aluminium or even in iron. In healthcare, just to share with you, during the pandemic, the ventilators had to be manufactured, and the government of India gave an order for about 5,000 ventilators to one of the company like Maruti. And when they tied up with a company like Agwa Health, who were the designers of the ventilator, the parts had to be supplied. And how do you make those parts? Most of the 3D companies were making windshield, were making using FDM system, windshield and applications like this. So they came to us and we used our 3D printing facility to make close to 1 lakh parts which were airtight, non-reactive and could function very effectively because they were made in PA12 nylon, and with the PA12 nylon it is FDA approved for skin touch. So these are things which can be done in consumer electronics. It's more or less the fluid and air ducts, snap fit, housing, living hinges. When I say living hinges, they are functional hinges. And in the consumer product, the prototype is a very critical application and we can do that. Or even fluid vessels. So there was a company which was making the RO system, and on top of the RO system to supply the water between among the three cylinders, they had a part which was 11 pieces, and there were seals which were there in between to move the water from another pipe to another pipe and another cylinder to another cylinder. They came to us, we looked at the design and we said, why can we not print it out in 3D and just fix it up on top? And they fixed it up, and that took away all the seals, that took away all the assembly and could reduce the cost significantly, and at the same time made the system very, very reliable. In the case of industrial services, just hold on. Sorry about it. There was a little noise coming from the office. Okay. So in industrial services, there are companies which are making the impellers. There are companies which are making the pumps. There are companies which are making the air conditioning. And there are companies which are making special purpose machines. And I did share with you an example of how it can become very, very effective. A company which was making a robot, the end effectors and the vacuum gripper was a critical application, because without that the part cannot be held, and every time there is a different part. So using a 3D printing, they were able to test it out, found it reliable to use it for end effectors as well as for vacuum grippers. So it's being used by different companies. I just took examples of the industrial applications for you to appreciate how 3D printing has already been used globally. You can see companies like Nike have now created a new set of shoes for which are called the power shoes. So company like Nike and all other sports company are today using the 3D printer to make the sole using the TPU material. With that TPU material, they are able to give far more flexibility and a push to the athlete to be able to either jump or run much more comfortably and at faster speed. Company like Walt Disney is using it for creating the characters which today are being used as a characters for the movie. And many of you may know Bahubali was completely shot using the models created in 3D printing, including the fort which you saw as such a big thing. It is under the VFX technology you are able to combine the characters and are able to combine the embedding of the live characters inside the dummy characters which are created using the 3D printing. So these are few of the examples of how 3D printing can be used. Today, there is a large number of looking at this whole scenario of expanding market. Large companies, which are many billion-dollar companies, have re-strategized and have started working on materials which are best suited for 3D printing. Companies like Arkema, BASF, Dressler, Evonik, Lubrizol, Henkel, these are not small companies. They are all $50 billion company plus. And they found, looking at the future, that there is a need for them to develop the material for the 3D printing now so that they can take the leading position at later point of time. So 3D printing has moved If we look at the right hand side chart, maybe I'll expand it. If you look at this chart, there was a big hype, and that was about 10 years back. The press was talking, the people were talking, the stock market was talking, and everyone felt that this is a panacea and it would replace all manufacturing. It did not happen. And then came the period of disillusionment. And that is a period when the market actually started coming down. So it had its up, lot of hype about 10 years back, then it came down. So people started acquiring one company against the other. But good thing is, with the momentum which has been gained now, it is now possible to, it is now started expanding. And today we are talking of a growth rate of close to about 29.4% as of last year. And last year they did a turnover, the 3D printing industry was about $20 billion, and it is expected with 29% or a higher growth, they may be able to hit double their turnover. The 3D printing technology companies may double their turnover in about 3 years' time. So this momentum is not just because the 3D printing technology has grown. If you look at it, the hardware companies like HP, G, DMG, Stratasys are all big companies which started doing the 3D printing. Companies in the material companies like BASF, Henkel, Arkema, DuPont, Lubrizol, Evonik, and many more started developing material. Software companies said that 3D CAD is fine, but now we need to do design for additive manufacturing. And they have now all built-in modules like companies like PTC, Siemens, Dassault, all have developed the module for design for additive manufacturing, which does take care of the lightweighting, does take care of integration, and does take care of many other things which add great value in terms of a new process of manufacturing. Companies like FEA, companies like ANSYS, Nastran, Altair started developing software because who will do the simulation and check the reliability before the part is used in the actual sense. And like it happened in the photocopier, initially there would be a lot of support companies which would come in who will do the manufacturing rather than the end user buying the equipment, which is what has happened with companies like GKN, Shapeway, Sculpto, Fortune, who have now invested in 20, 30, 40, 50 machines to be able to produce the parts for the various people. Let's look at the technology. What is the technology? On the number one, if you see, that's a small consumer product which we wanted to manufacture. We created a CAD model, as you can see it in the number 2, and then what we did, we sliced it up in smaller layers, thin layers, and these layers may be looking large here, but they are layers of 100 micron and even 2 microns, depending on the application. So 100 micron is close to 0.1 millimeter, which is what is the standard which normally people use. So you divide the whole CAD model into layers, which are then printed layer by layer. So what happens is you print one layer and then the bed either goes down or the bed goes up on which the print has been done, and a new layer is printed on top of it. That new layer adheres to the previous layer, and since it attaches to the previous layer and in many processes it fuses with the previous layer, you are able to produce the part like a cup layer by layer and thereby create the product on which you can do post-processing, you can do anything of painting and things like that. Let's look at one of the technology in a very simple way. Can you see the screen? Hello?
Yes, sir. Yes, sir. It is visible.
Okay. So if you see the screen, there is a roll in which the plastic material, which could be PLA, which could be ABS, HIPS, any of these materials, comes down, directed by the pinch rollers, and then moves down onto an extruder. This extruder is a heated extruder. So typically for a material like ABS, it would be heated to a temperature of about 270 degrees. By doing that, you are able to melt this material which was coming in the form of a wire and then print it out. Now, when I say print it out, what does it mean? It means basically the model which was there as you saw it in the form of a cup, and when a layer is sliced, it is almost like writing it down on the previous layer, or in a CNC process, the G code get created, and for that layer, the tool moves. In this case, the extruder moves on the Cartesian coordinates to be able to extrude the material only at the places where the extruder is moving and thereby create the geometry. Let's have a look at it. In this, can you hear it? The voice?
Yes, sir.
Okay. So the plastic is coming down, melt, and you're printing it out one layer at this point. And you would observe the bed goes down, next layer. The orientation. So you saw the basic system. Now this was called the FDM technology. Now Cartesian coordinate is critical. The extruder is critical. Some way of maturing the plastic is important, or a metal is important. The same principle of layer by layer printing is adopted in all technologies. So 3D printing is nothing but layer by layer manufacturing. So there is a second technology which is called the SLA printing. In the SLA printing, instead of moving the extruder on a Cartesian coordinate, there is either a mirror or there is a lens combination, and a laser or a light source comes in and hits the mirror. This goes get directed, and this mirror is the one which gives the orientation so that the geometry or the G code can be followed. So here you fill a tank with a resin, and this resin is photosensitive. So it can be cured as soon as the light or a laser falls on it. At that spot, it gets solidified. Otherwise, it's semi-viscous material. So being photoelectric material, it gets sensitized and thereby start producing that layer at the place where the laser is defining like a pen, writing it on top of the resin. So having done that, the bed either goes down or the bed goes up, and then you get the second layer and third layer and fourth layer, and thereby the product get produced. Let's have a look at it. I did it make sense? Hello?
Sir, actually, due to some bandwidth problem in internet, the voice was not clear.
Okay. But they could see the screen?
Yes, sir. Yes, sir. It was visible.
Okay. So the next technology is called the laser-based and direct energy deposition. In the laser-based technology, instead of a resin, here you spread the powder. Here you spread the powder on the bed, and this powder layer can be 50 micron, can be 80 micron, can be 10 micron thick. And then, as in the stereolithography, the laser comes in, get reflected, and it creates a spot which hits the powder. Since the laser carries a lot of energy, it melts the material, whether it's metal or it is plastic. So depending on what powder has been spread, we use the laser corresponding to that. So it can be as high as 2000 watts of laser, but typically you use 100 to 200 watt lasers. With that, you are able to create the geometry on the powder bed, and then the bed goes down, a new layer gets coated, and again the same process is followed as per the geometry. In this, the limitation is that one, maintenance of laser is a bit of a problem. Two, the moment you have used one type of powder, changeover of the powder becomes a challenge, because you have to clean the whole machine because the powder has been spread all over the place. And since the powder has been placed all over the place, the cleaning becomes a bit of a challenge. This problem to some extent was overcome by direct energy deposition, which you see it on the right side, and I'll show it to you. And I have given the references at the bottom of all these examples, so you can actually have a look at it. Maybe Mr. Rajkumar can share these links with you, and you could then go through it at length. So here what happens is that the powder is kept on the top instead of spreading it on a bed, and then the powder comes through the tubes like this. And when the powder has come in, the laser comes from the middle. And since the laser is coming from the middle, it is no longer forming an angle. And since it's not forming an angle, the accuracy becomes much higher, because then every location has the same power. In the previous case, if you had observed, the lens had to be moved uh, to position the place where the laser has to hit, and at the edges it was at an angle, and therefore the distribution of the energy becomes very challenging. In this case, the powder is at the top and the powder comes down, the laser melts the material, and like an FDM, it creates a melt pool with the help of which you do the printing, and then this head itself moves in the XY coordinate to be able to ensure that your geometry is driven. In case of metal, you have to do little bit of precaution, because metal do get oxidized, and since they do get oxidized, you have to provide a neutral gas like argon or helium while doing the printing. In metal, in plastic you don't need it. So let's look at it as to how it works. I hope it made sense to you to look at the three different technologies, which was FDM, which was SLA, and which is powder-based metal sintering or powder-based plastic sintering or direct energy deposition technology. These are all technologies which are there for last 15 years or 20 years. Actually, Mr. Chuck Hull, who was an inventor of the 3D printing, started working on it about 37 years back. So it has grown, but till about 5 years, it was more of a form and fit and for looking at what the product was. But now it is being adopted and gradually being moved to functional parts and more important, the production parts rather than only the prototyping. So a company like HP, who launched the product about 3 years back, re-looked at it, what can we do with the laser? And they created and used the technology with their best at, which is the inkjetting. So they created about 15,000 nozzles on the bed like this. And with that 15,000 nozzles, they almost print a page the way inkjet printer prints. This ink is thermally sensitive ink. And since it's a thermally sensitive ink, and with the precision level with which they could write it down on a piece of paper with the inkjet printer, the same accuracy is introduced while dropping the ink from the inkjet. And having dropped the ink, then there is a fusing lamp which comes in and then do the heating of the places where the ink has been put. So typically the temperature, let's say if we are printing it in nylon, the temperature of the nylon is raised to about 140 degree. Then the spread of ink happens. Then you increase the same fusing lamp because this is a heat absorbing ink. The places where the ink has been spread, the temperature goes to about 165, 170 degree. And at 170 degree, the nylon melts. And therefore, you have been able to create a fusion with the previous layer rather than adhesion of on the previous layer. And since the fusion is happening, your part becomes very, very strong. The speed at which the printing can be done is much better, and the reliability is much better. Let me show you how does this work. Rajkumar, could you hear it this time?
Sir, actually, voice due to video streaming, the sound, either the sound or the video streaming will suffer. So sound was not there, but the video was clear.
Okay, I can then explain it instead of.
Sir, it will not, like your voice will also not be audible at that time?
Sure.
Because there is a like it is the issue of internet actually.
Okay, okay. So the next technology which I'm going to touch upon is the continuous carbon fiber. So they wanted to strengthen the parts and they found that the fiber, so typically you would have the powder which would be melted and then the printing is done. If I could provide a reinforcement to the part, like I would do with the steel bars being introduced in the RCC to give it the flexibility as well as give it the strength. So it takes care of my compression and the various forces which get applied in the same way in the part. If I could reinforce with a continuous fiber, and that fiber can be either a carbon fiber or can be a Kevlar fiber or a fiberglass fiber to be able to print it out while the printing is happening in the powder or in the plastic. So Markforged was one of the companies which introduced this concept about 4 years back. And today they have delivered close to about 15,000 printers across the world for real applications every day. I think NIET already has that printer with them. So if you see the left side part, could you think that this part could be a single part or can be manufactured as a single part? Practically, you would need at least 20 different components and then we'll need to assemble them. But using a 3D printing and layer by layer approach, you could print it out and could use it as a circular saw housing. So that's what this is, a real example from Siemens, who were making the circular saw housing and they needed to test it out, they needed to print it out and then had to go to the market with the circular saw housing, which was a new concept they had introduced. And the whole jigs and fixtures was what you see it on the left side. If you see the middle one, and if you see that actually these are the cavities which have been created, these cavities on the left side, if you middle picture you see, they were actually material which was not needed. And if I could create a cavity, I reduce my time of printing, I reduce my weight, and I reduce my material consumption. And by creating these cavities, I also provided an air cushion, which was not possible. So it effectively improved the reliability of this part much more. Similarly, an actuator housing, which was, if you see, these are 4 components. Typically, you would do it by as 3 components, then do the machining, then do the boring and all those things. In 3D printing, it came out as a single part. So you could print in metal, you could print in plastic. And if I share with you this also, so in the metal, the technology which you saw and this technology, it becomes almost like a desktop. So here is a metal wire. Here is a wire which is acting as a support wire. So you saw the guy clipping it out with the help of a clipper or sometimes the CNC machine if the joints are very strong. But in this case, what they do is that they do the printing on the bed like an FDM with the metal material and they envelop it with a small plastic so that the parts remain stuck. And this is a technology which is well proven in the metal injection molding technology. So you normally put a small adhesive in the metal powder while producing the part, and that is called a green part. Now for creating the support where there is an overhang, you would typically do it with either the same material or a different material. But in this case, it's with the same material, but between the support and the part, there is a ceramic layer which gets laid. And since a ceramic layer has been laid, which when sintered become brittle and can be broken, and therefore all the supports can be removed without any CNC operation or your hard work in clipping out all the support elements. So it was a marked improvement over what was being done in metal. And same way as you saw in HP, it was a marked improvement when compared to the typical FDM SLA printing or volume printing. So let's look at an example of how this is done. Today, apart from the metal and plastic, a new area of 3D printing has also emerged, which is called the bioprinting. In the bioprinting, you use the gel and you use different materials mixed together to be able to create a print of the bio tissues. So scaffolds get printed and then the testing of medicines can be achieved on a specific type of tissue. So you, instead of general dosage being given and then doing the testing, hoping that the medicine would reach that tissue and hoping that it would not have any side reaction. But with the help of bioprinter, you can actually culture the tissue and do the scaffold, the way the tissue is built up or an organ is built up, and on top of it, you can apply the medicine, you can apply the chemicals, you can try the different reactions and create the bio system. Having done that, you are able to improve the testing process. You are able to do a focused and a targeted approach, and nowadays with the bioprinting you are able to even create organs which are now being used. So there are certain organs which were passive organs in the body, especially like to take an example, maxillofacial surgery. You have to do the jawbone replacement. Today, the jawbone replacement can be done very easily with the help of titanium or with a material like hydroxyapatite to be able to do the printing. A whole lot of bone joints like hip joint, like knee joint are now being done 3D printed. All the audiology examples, which is the earplug, and every ear is different. You would be very surprised to learn that every ear is different, but we are using standard. And when we are using standard, what happens? It keeps falling down. We keep pushing it in. That's not needed. So typically you can actually scan the whole of the ear and can make a customized earplugs which are good for hearing, which are good. I mean, I'm not talking of the fancy Bluetooths and things like that. I'm talking of the audiology applications where the people have impaired hearing and they do not want, they have to use it on a long duration. These days, even the people use these earphones on a long duration, and a customized earphone is a critical application. So all of them can be done as a part from 3D printing customized to the individual needs. I think another aspect which I would like to touch upon, it is an advantage why. When I say why, it's an advantage youth, because no knowledge exists and no knowledge is expected. Experience is expected. So it's a great skill for the youth to acquire and even be a startup company to do a new business. It is that we all know how integration of mobile communication, computers and internet led to the smartphone and what a large market it has opened, whether it's an app developers or it is the manufacturers or it is the maintenance people or even the sales people who are the sales shops where the large number of people are employed around the new technology called smartphone. And when did it happen? About 15 years back, and in 15 years back you have been able to create employment which is close to about 30 million people, 30 million youth having been employed. Even you and me ask whenever we get stuck from our son or daughter who is young enough and who has experienced enough the smartphone to be able to use the different apps. If it can create that much of an impact on the employment, I think 3D printing, which is affecting a $16 trillion market, not a small market, will have a large scope for growth. Having shared with you the technology, any questions related to technology or the trends before I jump into the applications?
Sir, there are few questions with us.
Yes.
One question is from one of our participant who is asking, can AM replace all conventional manufacturing process in future?
Today, no, because AM process is still evolving and therefore it's relatively expensive. But there are areas where AM has practically replaced the existing processes. When it comes to mass production of the same item repeatedly, the conventional methods are a lot more economical than the 3D print process, because 3D print process is meant for small batch volume, complex geometry, distributed manufacturing, lightweighting. If these are the key advantages which we are looking for in a product, it would be replacing the conventional process of manufacturing. Wherever we are only looking at, let's say, a dish plate being manufactured. Now, dish plate can be customized and dish plate can be standardized. If it's a standardized using if it's a malware equipment, right, you would typically use the injection molding and do the printing because the pieces which are required are millions of pieces. So it would not replace as of right now. But I cannot predict how it would happen 3 years down the line because it's growing very fast and catching up with the manufacturing processes. Any questions?
Sir, another question is, what is the role of CAD in additive manufacturing?
Okay, good question. If you saw my Gartner cycle of hype, one of the key elements in the hype which was missed was the role of 3D CAD. Because everyone thought it would become a tool which would go to every home. We forgot that before you do any 3D printing, you have to first create a CAD model. And we do not expect the child to be 3D CAD model efficient. So in 3D printing, you have to, for any object to be printed, you have to first create a 3D CAD model, then have to do the slicing. And there are standard softwares which are available for slicing with the parameters to be adjusted, which can be just entered. So you don't have to write a program like G-code program. So after the model has been done, you do the slicing And these slices are the one which gives me the G code for that particular layer of information. So if I don't have the 3D CAD model, I cannot do the slicing and therefore I cannot do the printing.
Sir, we are having many questions. Some are repetitive. I am taking one more from them. What is the market share of additive manufacturing in customer products in today's scenario?
It is very small. It is close to about $16 billion and in a market which is $16 trillion. So you can well imagine it is less than 1%. 0.1%, but it's growing very, very rapidly, and it is expected that between the conventional manufacturing and the 3D printing in the next 5 years time, it might go up to about $120 billion market.
Sir, we can move further because there are various questions which are repetitive.
Sure. So let's look at the applications. It's being used. So there are 3D printers which are game changers in the physical world. We can have 3D printers which can print chocolate, which is customized chocolate, ceramic, cement, electronic circuit printers, metal printers, plastic printers, carbon fiber printers, and even semi-viscous printers, which is like Play-Doh and things like that. So let's look at it. Who are the users? The doctors are using it, designers, sculptors, dentists, civil engineers, artists, chefs, toy and game designers, architects, furniture designers, interior designers, fashion accessory designers, aircraft makers, and the builders. And of course, the consumer goods and all those things. Take any example and you would find at least 20 people using it in that industry. So let's look at it how the doctors are using it. They are using it for dental. They're using it for audiology. And if you see on the right side, they're using it for creating the jigs which are used for fibula being cut for the jaw replacement. So they typically do the cutting of the fibula, which is the lower bone of the foot. And there are two bones. So you have one spare bone in the foot. And this bone is to be cut precisely as per the shape of the jaw, which is personalized to every individual. No two people have the same jaw. And then with that cut, they are able to do the surgery. Previously, they had to do this after taking out the bone. They were cutting it out based on the measurement. Now with the CT scan, they are able to check it up, do the planning, create the fixture so that as soon as the bone is taken out, they are able to cut it with the saw, and that is used for the jawbone replacement. It's been the whole science of dental is changing from the traditional cast being taken in the mouth to the oral scanning, and based on that you are able to create aligners, you are able to do various operations. I'm sharing with you a spinal surgery which could be planned much before in this thing. And another example of a cranioplasty where the cranium which had to be punctured for various reasons, it could be for cancer treatment, it could be for clotting or thing like that, you could actually do the replacement with a titanium or a hydroxyapatite bone, which could be put exactly at that location rather than cutting and doing the finishing on the surgery table. So these are few examples, and I'm just sharing with you the example of implant. So today, for your benefit, I'm just sharing no implant is done without 3D printing. Okay, so all implants are now being done using 3D printing. Look at the right side leg. Could you have actually manufactured this cover using the traditional method? Because it would have taken very, very long time on a CNC machine. But in the 3D printing, it became very easy. And since it became very easy, you could provide the comfort of lightweighting and at the same time the strength, which is a lot more flexible apart from rigid, which it comes in. A chocolate printer, can I do the customization of the chocolate and give it to the people as a gifting? And on the left side middle, you can see this is the chocolate printer where you could even do the mixing of the different chocolates while doing the printing. A cake printing, I could do direct food printing using the different type of material, including the dough, and using the syringe as my extruder, I can push the material and give the shape to my output. Can I create my customized cups? Can I create my customized glasses? Can I create my spectacles or my child shoe? All of it is possible using 3D printing. Globally, it's being used by various sculptors to create the cast and then do the sand mold casting with the help of it. You have seen the statue of Sardar Patel. That was all designed by one of the artists, the sculptorist in India. And after doing the designing, the same was given for casting using the 3D print output. I'm just sharing with you the different structures, including the furniture, which is typically put and which we all go as tourists to look at how great the work the sculptorist has done. Many of them nowadays are being done with the 3D printing, and you can see an example which was done in Netherlands, and this was a large structure which was created with a holes in it, and they put the lights in between to give it a very nice look in the garden. Can I create my toy which is personalized to my child? Yes, I can, because I can scan the face of my child, use it for doing the 3D modeling, and after the 3D modeling, I can create using a soft material like silicone in color and can print it out, and that become my personalized toy. Architects have used it extensively for creating the model, sharing it with the client, getting an approval rather than 2D drawings, and then talking about the planes, different planes from where the person need to see, and typically the reconstruction in an architectural or a civil world is close to about 3 to 5% of the expenses. With the help of 3D printing, they are able to avoid it because you are actually showing the miniaturized house or a miniaturized building or a miniaturized structure before the construction actually happens. So many of us have heard about house which has been made in less than 3 days time and could be a 8 meter by 8 meter house using the 3D print technology. It's being used for aerospace, and I would like to draw the attention of all of you to look at the right side, right bottom corner example. This is a part which is used in this to fix the seat in an aircraft. And if you look at this structure, it is a solid structure. The same was modified to the structure where the lot of material was taken away, and yet the strength was the same. Thereby, they reduced the weight of each structure by close to about 125 grams. Now, having reduced the weight by 125 gram, and if there are 300 seats and each seat requires 6 pieces of it, right? You can well imagine you're talking of 800 grams per seat, and 800 grams means 300 seats is close to about 240 kilos. 240 kilo means whole lot of fuel saving. And one of the companies which started using even the belt buckle or a seat structure like this were able to save close to about $100 million per year by just redesigning and reworking on the seat holding and the buckles. Organizations like National Institute of Fashion Technology in India and globally various fashion designers have started using it as an accessory developer, and customized shoes, customized belt, customized rings, customized necklace, and many of other things to be able to define and give shape to their dreams. Some of the examples I'm just sharing with you. It's been a challenge for them to create and be able to present their ideas to the world, but with the help of 3D printing, you are able to do that. So there was a show which was done in Bombay about 2 years back, which was all the clothes and everything, all the accessories were designed, made on 3D printing, and a full fashion show was held using the design and made with 3D printing, and the fashion show was held. You could use ceramic for doing the customized material and customized consumer products. Let's move to the industrial application. If you look at the industrial application, typically you would make a pattern using a wood. Now, when a wood, there are very few artists who can actually cut the wood in this shape. Now, and that would have to be maintained for a long period of time because the wood absorbs water. Using a 3D printing, you could make it in PLA or ABS, and there you could use it for casting applications for the sand mold casting. Of course, you would have used the same sand remover and all those things to give it a finer finish. A panel manufacturer could construct the panel and fit it in and could test the whole equipment with the help of 3D printing. Now, can it be producing it one piece by one piece by one piece? No, it's not necessary. Our production machines like HP is able to produce large volume of parts in one go, and not only one type of part, which was the limitation of the existing system, that you had set up a die to produce one type of part. In this case, I could actually create a bed or a box with different type of parts and multiple parts of either the same type or of multiple types. So this is an example of a company called PUC, which used to make the water meters and airflow meters, liquid flow meters. Using the flow meters, they had the casing. So in this case, the threading, the boring, the hole, the snap fits, all were done in one go, and you didn't have to do 20 different processes to make the part. And you could make multiple parts. On the right side, you can see at least about 50 parts could be manufactured in the day. Sorry. So you can see this was a combination of instruments and the lenses which had to be put in, and this whole structure could be 3D printed in one go, in which it is a housing in which it could be done. Using a metal machine, we were able to print the copper holding mechanism for the tool. As you know, before a changeover of a tool from one tool to another tool, you need to cool it. And to cool it used to take a lot of time. So using a copper mechanism structure, you were able to cool the tool much faster, improve the productivity. So I'm sharing with you another example. If you see, this part was broken, and this could be made in 3D printing. To write a CNC program would have been a challenge, right? You could make it in 3D in less than a day's time and use it for your repair. Another example of a company called Tecron Engine Component Supplier, which made the complete housing as well as the complete mechanism using the 3D printing. They didn't have this part, they didn't have the CAD model, so they could do the reverse engineering, and after the reverse engineering, they could directly produce it in 3D printing rather than going through the CNC mill process. Another example of flow, I will just reduce the size a little. Now, in this case, if you see, the flow tubes are at an angle. Can you do the drilling? You cannot. But can you change the flow direction? You cannot. So you would have cut the section wherever the tube was bending, you would have cut it into smaller sections, then provided a seal and would have created a housing for that and would have joined with that bolt and nut. The whole process could be avoided because I was doing a 3D printing, and with that 3D printing, it gave me the flexibility of making the curved tube and manufacture as a single piece. Another nice example which I really love because people think that the heat will be a big problem. This was a mining company and they used to put the crucibles, and to do the crucible they had to create a housing so that they can do the melting close to about 1000 degrees centigrade and then test the materials or do the fusion or give a shape. The whole thing, if you see on the right side, could be done using 3D printer and then could be assembled in the complete assembly. Company like Dunlop, which was making shock absorbers, used the 3D printer to create the shape. If you see on the left side, these are the anti-vibration solutions which were created, including the automotive air suspension components and electronic control systems for the after sales market or even during the manufacturing. Another example of design for additive manufacturing, I thought it would be relevant for many of you to understand that you could, this was the original part in HP inkjet printer, from where the guides used to happen. But we didn't need these guides. We had only the mechanism which was here. So why should the remaining portion be manufactured? It was redesigned, and in this case it was done in aluminium, which was redesigned in plastic with this structure. And then they found that there is no need of having a solid base. You could do this. Then we worked on the organic design, and using an organic design, you see the topology design which came out was something like this. The weight was reduced from 355 gram to 23 grams, and the it was environmentally better, and more important, it was lightweight, and it increased the efficiency and also made the productionable part rather than, so whatever was the cost of 3D printing got completely offset because now I'm using much smaller material and therefore my speed got increased. So these are few of the examples of integration of parts, which was typically a part like this required all these components before the manufacturing could be done. Now it is a single part which is being manufactured. So different examples I can share. This was a shop floor example where the cartridge had to be manufactured, and this cartridge are of different types, and since they are of different type, they had to change. The changing over time was a very long time. They made the whole thing using a 3D printer, and they could put alternate of different shapes so that the cartridges could be assembled and worked upon. Another example of integration of part and changeover of the part from aluminium and stainless steel to a plastic part, including threading, boring, hole, could all be done as being used. Look at a complex tubing arrangement which had 6 components and a curved pipe, could be completely done using a single part as an assembly, and thereby reduce the cost significantly both in assembly as well as in terms of manufacturing. I hope this gives you an illustration of how 3D printing can be used for different applications. I'll just like to take upon few more examples of a battery cooling system. Now, these are curved pipes, and these are of different dia at different dia and shape, which had to be made. I'm not changing the design, but I could practically make it in one go, a curved pipe like this, or an aerofoil, which would have been a solid part like this. If you see it in the brown color, what they did is that they inside made it a lattice structure, and with the lattice structure like this, if you see it on the right side, they were able to reduce the weight, which you would agree with me is critical for any application. Can it be used only in mechanical? It is being used extensively in electrical as well for doing the various example, and I'll share it with you some of those examples. A battery casing, oil seal. When you are doing the sealing, you need to put a cap, and the size of the pipe can be varying. You could make it. This is an example of a bellow being made using the 3D printing, using a material like TPU, and creating the suction with which the robots work. Here are a few examples of the electrical. Typically, these connectors are standard. Now they're great, but if I have two more pins, I have to provide another different type of a connector. Can I make my connector and insert my pins in which my electrical conduction can be done? Can I write my instructions on top of it using a color printer? You could do that. Or you could even do the testing fixtures with inserted pogo pins, or do the customized connector holders, or do the routing fixtures of different examples are very critical. Many of us do suffer the back pain, and we put the belt as the best solution today. But can the support mechanism like the girl is wearing be created which would hold my back straight and would be far more comfortable, and will also ensure that the right amount of pressure is inserted, is an example of a biomedical application. Same way, can I use the prosthesis and of the amputated legs, using the 3D printer? These are few of the examples of how the ankle joints or the knee joint or the complete leg replacement can be done. And they can be very interesting projects in your college with the various students as well. The world of braces on the teeth for correcting has been replaced with aligners. And so using the oral scanner, you do the scanning, create the 3D model, create the plan for correcting the teeth. And instead of visiting the doctor every time, today you can actually make clear aligners with the plan which has been done, and these can be inserted on your teeth, and therefore they can be removed while eating the food. Therefore it becomes more comfortable, and subsequently or in the night you wear it for the correction of the teeth. Many of us have flat tooth. Can I make the customized sole which can help me in overcoming the limitations of the flat foot? It's being done, and if you can see on the right side, I'm able to make about 60 patients' foot of different shapes simultaneously to be able to work on it. There are few people who are doing the project on the helmet and other examples. This is a helmet which is being used typically for correcting the growth of the bone on the head. Okay, and therefore putting the right pressure in. This is mainly meant for children, and using the holes, you are able to provide more comfort to the child because the air can circulate and does not feel the heat. Paralympic or examples. This is a very interesting example of a civil engineer who is using the 3D printing for doing the terrain modeling, both for the smart city and defense, using it for strategic wargaming and planning. So I just shared with you a whole lot of examples, and I can keep going on. So I thought that I will touch upon some of these examples and then have a discussion on it, whether it's a CNC lathe bar puller or it is the fixtures for the CMM machine. You could do all this work with the help of it. Now coming to the material, can it be printed in metal? Yes, you can print in 17x4 stainless steel, Inconel, tool steel, pure copper, titanium, and many other alloys. Similarly, you can use the plastic of different types, including the PEEK and polycarbonate, which are high density and high temperature plastics. Composites like carbon fiber, Kevlar, flexible material like silicone, rubber, sugra, clay and ceramic, which are like alumina, zirconium, porcelain, and gel, and including wax or any other material. So in summary, 3D printing is accelerating the design to manufacturing of the prototype, pre-batch production, spare parts. There is no MOQ, there is no inventory, there is no tooling. The geometry of part, more the complex the geometry is, it's a bonus. It helps in optimizing the design for weight and for reliability. It also helps in efficient supply chain with complete de-risking because you are no longer holding the inventory, and low capital cost to try alternative. It's a great tool for educational institute and for the students who are doing projects and the teachers who are trying to create models which they can use to explain the concepts. For both of them, it's an ideal tool because they can use customized models which can help them in explaining an assembly or disassembly of the system. It's being used by various physics teachers to explain the concepts. It's being used by applied mechanics teachers. It's being used by electrical people. It's being used by agriculture people. Very recently, we also worked with biotissue for the agriculture. Thanks a lot. I think I have covered up a lot of examples, and I would be very happy to answer any questions. Thank you.
Thank you very much, sir.
Thank you very much, sir.
Thank you.
For sharing your deep knowledge about 3D printing with us. Your session was full of enthusiasm and valuable knowledge. I end up with one of the quotes from Dr. APJ Abdul Kalam. Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge. Knowledge makes you great. We learned so many things and we got knowledge about 3D printing. Especially from your session, we got a chance to realize the colorful and various objects manufactured by 3D printing with applications. So thank you very much, sir.
Thank you. So should I
Sir,
close? Yes.
Sir, actually, we are having a lot of questions. I will write them to you. Actually, we are running out of time. That's why we cannot take all those questions. So
Sure.
thank you so much for your informative talk. It was very wonderful and it is always very knowledgeable. So thank you so much, sir.
Thank you. Bye.
Bye, sir.
Thank you,
Thank you, participants.